Since we're up to 8, we almost have half the class, so I'll go ahead and record, and then I'll debate on if I want to post it to the internet. Alright, so, starting off, I'm going to just drop a text box on a page so that we have kind of something visual to work with. So text box, multi-line, just go ahead and dock it to all corners. Dock fill. Alright. So that'll kind of be our space. I was debating on a Windows app versus a command line app, but I figured we get a little bit more flexibility in formatting with the Windows app, so I'm working with that. Alright, so what I want to do is I just want to hook in. I'm going to hook into the form load. All these tasks we're going to do at this point is just going to be on the form load. What does that look like? What does that mean? When you're dealing with the file system, whether it's local file system, CD-ROM, floppy disk, hard drive, USB stick, any of those things, or a file system that's accessible via a share, so any sort of UNC path, SMB type share, you will use the namespace system.io. Okay? So I'm actually going to go ahead and promote that into the using statement. Now, what's inside of system.io? You have readers, so ways for reading and writing data. You have what I kind of consider to be utility classes for dealing with files, for dealing with directories, doing basic file system operations. Create a directory, find all files, does the file exist, delete a file, open a file for reading, open a file for writing. Those types of mechanics live inside of the directory class and the file class. So the directory class contains create directory, delete, enumerate directories, enumerate files within a directory, exists. You can get the access control, which is sometimes referred to as the ACL. And that is when you go to a file in Windows, you right-click on the file, you go to Properties, there's a Security tab, gives you the permissions. That's what those access controls are. What permissions are on a file, and then being able to manipulate those permissions a little bit. And then other kind of utilities. Create date, create time, get the directories, subdirectories, allows you to navigate drives that are mapped to the system, so logical drives versus physical drives. Then you can kind of go through. Files, same concept. Copy, create, decrypt, delete, encrypt, exists. Does this file exist? Get last access, get created time, open for read, write, text, read bytes, write bytes, replace. So a lot of those things that you kind of just take for granted when you're dealing with Windows, because you just drag and drop and file save and boom, things just happen. So these are those under the hood pieces that kind of facilitate that. A lot of the information that you pull out will end up getting stored inside of either file info or directory info. Those are two classes. You have a series of enumerators that are used when opening or creating files, so file shareability, file options, modes for files, and those modes usually consist of, do I open it for create, open it if it exists, do I create it if it doesn't, or open it if it does, do I open it for read, do I open it for write, those kinds of things. These are kind of flags or attributes that you're kind of feeding to the file class when you're creating streams. So yeah, file streams themselves. Deep under the hood here, you actually have stream, so that's the base class for all stream constructs within the .NET framework. Everything inherits itself from stream. So of course you have stream readers. You then have higher level string readers, text readers, unmanaged memory accessors, and one of my favorites is the file system watcher. And there's more in there as well, and there's a lot of exceptions and things like that. File System Watcher is fun because you basically give it a series of attributes and you say, look at either this file by name, look at these files by extension, or look at files that match this pattern. And whenever something changes in one of those files, trigger an event and then do something with it. So what's an example of that? For the school district I work with, I also do the football games, Friday night football games, and we have a pretty nice LCD display. So we're doing playbacks and all kinds of stuff. And one of the things that the supervisor up in the booth wanted to do is he wanted to be able to stream stats for the game. We wanted to put them at the bottom, just like a NFL game. So we started off, and the system we use would take XML formatted text, and that was what it used to push the projections onto the screen. So there's a special format, and it was already set up, and then there was an app tied to the front end, or as the front end of that XML document. So what he would do is he would go over to the stats guys, which were a room over on their own computer. He'd say, hey, run me off or print me off a copy of the stats as of this point in the game. They'd print them off, he'd run them back, he'd give it to me, and then I'd have to sit there for 5 minutes and then punch in all these stats. Save them, push them out to the display. Pain in the butt. One day I said, well, let me go over and look at the stats system. So we're looking at the stats system, and we realize that every time he tells them to do a print, the printed page, which is always in the same format, just with different numbers, it also creates a flat text file of those stats. So I said, well, if you just tell them every 5 minutes or every so often after every play to run that print process but don't print, I said it's going to generate this new file. I said we can then pick up that file and do something with it. So he told him to do that. We then wrote map to share on that machine, took the File System Watcher and said, look at this file on the disk. It was always the same file name. So every time that trigger would happen and they would generate that new file, I then had an app that was running in the background on my machine that would sense that change, pick up the file, parse it, read it, convert it into XML, and save it to the disk, which then the vendor's application would pick up that new XML document and push stats right out on the screen real time, or relatively real time. So things like these little widget tools of like the File System Watcher can have a lot of potential when you're trying to deal with automating processes. Things that normally you would think of, well, I got to launch an app, probably something command line based. I'm going to have to put it inside of a loop, and I'm constantly going to be having to hit the hard drive, either infinitely or on some sort of regular interval. Well, these types of classes are actually hooked into the subset of the operating system, and it gets unique calls from the operating subsystem, letting it know when the file is changed without it having to watch the file, constantly taking up CPU cycles. So, I share that story just as a point of reflection. All right, so file. So the file class has an open method. Open has two additional overloads besides the give me the path of the file, file mode, file access, and file share. So to do this, the process I want to go through is I want to open a file from disk, show contents of file in the text box. Okay, so that's what I want to accomplish. So to do that, let's start out by creating a file. So the first thing we need is the path to the file. So that's going to be a string. And for my desktop, it's at C users Gantos K / desktop. And then that file was cpweek9.txt. Alright, so that's the full path to that file. The next parameter is file mode. So we can open this, yeah.
Does the file path require it to be the same case, like CP week 9? If that was lowercase CP week 9, would it still detect that it's the same file?
On a Windows operating system, it will detect that it's the same file because Windows file system is not case sensitive. If you were to compile this and deploy it on a Linux box using Mono, it would treat them differently because the file system itself will treat them differently because it is case sensitive. So that's a determination of the operating system itself. So file mode says, okay, to the system, open this file. How should I open it? Should I open it for appending, which basically means that it's going to open the file and it's going to seek to the end of the file, and then anything we write to the stream will write to the end of the file and append. Create will spin up a new file, create it, and give us a stream to the new file at the very beginning. Create new will go in and actually create a new file, and I'm going to kind of come back to this and explain a little bit of it. And it will whack an existing file, so it requires write permissions to that, and it requires delete. So if there's an existing file, it will whack it and then attempt to recreate it. So if we look at create, or maybe I have them backwards. Yeah, and this is going to show up and disappear. So create will whack it and recreate it. So if you say create, the file exists on the file system. It's basically going to truncate the file, delete all the contents, and treat it as a new file. Create new will go to the disk, create a new file, but if an existing file is there, it will actually throw an exception saying, sorry, this file exists. Open opens the file at the beginning point of the file itself, so if there's contents in it, it'll just open it. If the file doesn't exist, you get an exception. Open or create will open the file if it exists, or create it if it doesn't. And then truncate simply takes the file and truncates it, and then sets it kind of back to 0 bytes. It doesn't actually, I think you then have to do a subsequent open if you want to go in and write to it. It just does kind of a quick truncate, wipes the bytes, and sets it back to 0. Alright, so in this case we want to do an open, and then we have file access. We can have read, rewrite, or write. So how many times have you run up against, you're doing some work in something and you try to, I guess I see this probably most often where I'm looking at log files. So I have a log file that's open and I'm trying to do some work within it, and the file comes back and says, sorry, this file is locked. So you try to open up a Word doc, somebody else has it open, says, sorry, this file is locked, you can't even, sometimes it won't even let you read from it. Sometimes it yells at you about that, but definitely won't let you write to it. So giving file access read means that I am locking it only to read it. If someone wants to come behind me and write to it, they're permitted to do that. That doesn't mean that what you're reading will get modified necessarily, depending on where the writing is taking place, but other people have write permissions to that file. You're kind of opening a copy of it, almost kind of a feel. If you're reading the stream live as data is being written to it, you'll actually receive the stream of data that's being written and flushed to the file. Read write gives you the ability to read and write, so you can read from it and write to it. So if you're wanting to read data from it and then write to it, that's read write, so basically you have full control over the file. Write only means that you are not going to be able to seek around within the file. The file will open, depending on the file mode that you use. It will either put you at the top of the file or the bottom of the file, and then you simply have the ability to write into it. You can't read from it, you can't seek through it, and you're locking write access to it. A file share, when you utilize this in conjunction with the file access, gives a little bit more permission to other users. So this is how do you want to treat other users when you're dealing with the file. So if you set your access to read, you can set their access to write. You can set their access to read write. You can set their access to none, which basically locks the file, no one can use it. You can set it to delete, which means that they cannot open it to read, they maybe not open it to write, but if they choose to, they can just go in and whack the file completely. And then you can inherit, which I believe takes on the properties of the operating system itself. So whatever the operating system's preference is, it will just kind of inherit that default. So we'll say read, read, write. Now the type that it's going to return is a file stream. Now, some of you may have done this in the past projects when it came to opening files, saving files. A lot of you like to use the rich text box because it had load file, save file methods, pointed it to the path, and it would just do the work for you. We're actually going underneath that, and we're walking through how to actually read and write from the stream itself. So now we have a stream. We kind of have a, what's a good way to think of it? So you have hold of this stream, and you're kind of looking at it through a magnifying glass. So if you've ever been to the zoo, and they have, in the insects area, they have this little like tube where the ants walk through, and then they have little magnifying glasses and spots inside, and you peek in, and you're kind of watching the ants as they move through. The file stream, think of it kind of that way. So you're now attached to this stream. The stream may be actively moving, or it may not be actively moving, depending on the type of stream it is. File streams, for the most part, unless you're reading from it and allowing people to write to it, it's usually pretty stationary. So you now are at the front end of the stream of text, or the stream of this file, and you've got this magnifying glass. And your responsibility is now to walk either one byte at a time, one word at a time, one line at a time, or all the way to the end, and read the contents of this file out. So if you look at your options for the file stream, you have things like begin read, begin write, end read, end write, flush, lock, position, length, read, seek, write, write async, write byte, and there's also a read byte and a read async. So I guess let's kind of go through the mechanics of what the properties mean first. So the length. Again, talking about files. Every file has a size. That size is referenced as the length when you're looking at it from a stream's perspective. So the length of the stream is the size of the file. So and normally it's measured in bytes. So if you have a 10-byte file, the length of the stream will be 10. You have a 10K file or a 1K file, the length of the stream will be 1,000. 1,000 bytes in a kilobyte. 1024 technically. But so that length has to do with the size of the file itself. the name is not really relevant in this case. The position is where you are between 0, the beginning of that stream, and length, the end. So your position is, you open the file, you're starting a new file, you're at 0. You're opening a file that exists and you haven't seeked to a specific spot in the file, you always start at 0. Your position is 0. Seeking is moving from whatever position you're at to a new position within the file. So certain file formats have byte, not limits, but byte separation. So the first 100 bytes inside of a file represents X. If you ever open up a JPEG file inside of Notepad, you'll notice that the first 5 characters in there usually consist of some little funky diamond and then JFIF or JPEG. That is part of the header for that file. So the first, I guess it's technically, it's more than 5 bytes, but no, maybe it's just 5 bytes. Anyway, that first set of bytes in just about any image file is part of the header that identifies the file format. So if you ever try to open up a JPEG in Photoshop, but it has like a PNG extension, Photoshop will yell at you and say, hey, the file extension and the file type don't match. Or if you get this random file and you don't know what type it is, you can open it in Notepad, assuming it's not too big, and you can actually see the file type. Zip files, you have a small enough zip file, you open it up in Notepad, you'll actually see the first 2 characters inside the zip file are PK. Every zip file starts with the letters PK at the beginning. That's in the header. So the first 3 to 5 bytes identify the file type. If you open up a docx file, I don't know if anybody knows this, the newer Office formats, docx, XLSX, PPTX, those, you open them up, they have PK in the front. You can take those files, change the file extension, you can unzip them. They're just zip files. The old documents, the old Word docs, the doc files and so forth, they have DOC in the front. So that concept. So if you have a particular format and you know where you need to read from inside that file, you would seek to that point and then begin reading the data out. So instead of walking 1 byte at a time, you can seek to where you need to be because you know that this file should have the right format and begin reading from there. That's often the reason you end up seeing like corrupt file errors, is that it expects to be able to go to position 35 and say, okay, I can start reading data from here. It gets to 35 and it does not get what it's expecting. That's where you end up with file corruption. So that's what a seek does. Read will read an array of bytes starting at position X, the offset, and reading Y number of bytes, the count. So if you wanted to read an entire file into an array, you would say read from offset 0 to length. That'll read all the bytes. Read them into an array. So you now have an array of bytes that basically represents that file. I won't get into this too much right now because we have a whole series of things on asynchronous, but the idea is if you're reading a very large file and you run a read on that file, we talked a little bit before about event handlers and thread locks and how you want to handle things with events versus doing loops. Asynchronous processes spin up secondary threads within your application and run those tasks on that thread. They're a little more complicated to deal with. They've gotten a lot easier to deal with in .NET 4.5. But basically what you're doing is you're saying, go start this task, run it over there, and when you're done, let me know, and then I'll come back and clean up and carry on doing the next set of tasks. The way you can identify them, they either have the word async, A-S-Y-N-C, or they usually, well, that's not what I wanted it to do, or they have prefixes like begin X, end X, begin read, begin write, end read, end write. So the begin method is here's the setup, go start doing it. And then when the asynchronous process completes, it sends you back an async wait handle. That wait handle is your kind of ticket to say this is the process I started. You then go to the end task, end read. You give it the ticket. It then takes that ticket, figures out which async process you were doing, and then returns to you the value you would expect back. All right, so doing a read, we need three things. We need a byte array that can hold all the bytes. We need to identify the offset and identify the length. The byte array must be able to store the same number of bytes that your count is. So if your count is 10, your byte array must be able to hold 10 characters or 10 bytes. If you want to read the whole file, your byte array needs to be big enough to read the whole file. So how do we declare a byte array that's big enough to hold the whole file? Not a rhetorical question. Okay.
Would a for loop where you increment it to increase by 1 every time work, or would that just be?
That would be a process for if you wanted to read it one byte at a time, but I just want to declare a byte array that's big enough. All right, so we have to go ahead.
fs.length.
Very good, thank you. That would be the file stream length would be the size that we need for that byte array, the buffer. So there's our buffer. Our offset is actually the offset as it relates, and I always get this mixed up. It's the offset within the array. So where do you want to start in the array? Because we're starting with an empty array, we're just going to write to the beginning of it, position 0. We could read this file in chunks, where we're reading 100 bytes at a time or 10 bytes at a time, so that we would always want to start writing into the buffer, into the byte array, at a specific point in the byte array. We wouldn't want to always start back at 0, because then we just fill the first 100 bytes every time. We would never get past it. So in this case, we're going to start at the beginning, and then the count will be fs.length. Again. I bet length is not an integer, it's a long. Because files can be very big, your length on your fs is a long, so you end up with casting issues. Easy way to work around this is your buffer.length, because the length on the array is always an int. So that's another good thing to know. It's not a direct limitation. I've never seen it documented as a direct limitation, but your arrays, the length of your array is kind of constrained by the size of an integer. I forget the number for an integer. It's a pretty large number, but it's constrained by that size. So you can never store more bytes in an array than what the size of an integer is. And I think it's like 3 million something. So it's a pretty big size, but when you're talking about bytes, 3 million is really no more than 3 meg. So you can't read more than about a 3 meg chunk. And I may have my commas off sometimes. I don't know. So if you want to look it up for specifics, you're welcome to. But either way, you kind of have this finite size that you kind of have to deal with. So that's something to keep in mind as you go through this process. All right, so now you'll also notice with read that it returns an int, and the int that it returns is the position within, I thought I was going to say it in there, is the position within the string, so where it stopped in the string. Since we're reading from beginning to end, there is no stop point, so we'll just get the end of the stream. So now we have an array of bytes. What do we do with them? This is when you start talking about this concept of serialization. So you now have an array of bytes, and how do you convert them into something meaningful? Well, depending on how you created the array of bytes, you have to reverse that process. So when it comes to texts, you do what's called text encoding. Within the .NET framework, under the system.text namespace, you have a series of different encoding options. You have ASCII, you have down at the bottom, you have UTF-32, UTF-7, UTF-8, Unicode, which is actually UTF-16. So you have all these different text encoding options. Since we're dealing with text, we can use these encoders. Something that I've always found very unusual is that if you go encoding, you get instances of each one of those types, those classes. If you go up to the top and you go ASCII encoding, you get an instance of each one of those types. It's the same. I'm not really sure why. I think it has more to do with the inheritance, because they all inherit from encoding. So all of these types are kind of defined inside of encoding. But then it's kind of this like paradox of there's instances, but they were all inherited from the base type. So it's just, alright, if you don't care, I don't care. ASCII. So we need to take from our bytes and get to a string. So there's two methods to keep in mind. You can say get bytes. You pass it a string, it gives you bytes. Takes your string, ASCII decodes it back into bytes. So assuming that your string is just ASCII characters, it decodes them or breaks them down into an array of bytes. Get string takes an array of bytes and encodes them up into ASCII text. So we can then take our buffer, pass it to get string, which will give us our text. From here, we can say textbox1.text equals text. And there's our text. All right. Now, just something to think about, and I'll do a couple of small things here. So I'm going to start by getting rid of the text box. I'm going to go back into my toolbox. I'm going to go under menus and toolbars. I'm going to add a tool strip container. I'll dock it to fill. Inside of here, I'll put my text box. So I now have a space for a toolbar. I can also add a menu strip. That's not what I wanted. Delete. Delete. what I was wanting to do was this. Not sure why it was being so difficult. Putting the ampersand in front of the character treats it as a hot button or a hotkey. So if you want to be able to do Alt F0, you're a keyboard junkie, you like to type instead of clicking, don't like to take your hand off the keyboard, putting the ampersand in front of the character makes it the hotkey. So let's put our text box back. F5. So I can go Alt F0. Don't have anything hooked to it. It'll do the file open. Go to my dialog boxes, add an open file dialog, wire this up to say open dialog1.show. Equals OK. Open file. Open file dialog 1. File name. I'm going to generate a stub method. I'm going to take all of this and I'm going to move it into my open file method called pFilePath. And then I'll replace this parameter with FilePath. So what's happening here is click open, opens the dialog box, pick the file I want it to open. That file then gets passed to open file. Open file opens the file, puts text in the text box. You can do a quick check here and say if file.exists. Open it, else message box.show file doesn't exist. So it does its own little check there. It's nice. So now you can open up the file. Okay. So that was opening a file. There are other kinds of streams that you can open as well. Most common kind of stream is one across the internet. Open up a socket, make a request, receive some data. So if we do an equivalent, private void open URL, string URL, we want to take that URL, website address more specific, and open that, read the contents of the web page, and then load them into a text file, or the text area. So how do we do that? Network and network streams are located under system.net. There is a HTTP web request class, which is what you use to make a request. And then there is also system.net.http web response, which is the website is the response the web server gives. These are slightly less intuitive on how to use. It's not new HTTP web request. This will give you an error. And it will tell you that there is not a valid constructor for creating a web request. It's depreciated and it will throw an exception. Instead, it has a static class called create. I'm sorry, static method called create. That method takes a URL string and gives you back a web request. Not an HTTP web request, but a web request. So you actually have to go through the step of casting it back to HTTP web request. I can do my capitalization. Use the namespace. Alright. So we now have a request. The request has a whole slew of methods around, you know, are you using a proxy? Are you doing this? Are you doing that? Do you need to include cookies? Do you need to do any of this stuff? Stuff that a web browser does. So if you were wanting to build your own browser engine from the bottom up, you would use the classes inside of this namespace. If you just want to build a quick and dirty one, then go back and use the web browser control because it is a pain in the butt to build your own web browser. Alright? So, we just want to simply go out and request the HTML off of a page. What I want to see is I want to see this. That's all that we're going to achieve by doing this work right now. Is we're just going to, that messy. All we're going to get is that dump of HTML. We're not going to get any pictures, we're not going to get any style sheets, we're not going to get anything pretty. We're just going to get a dump of the text. Because what the web browser does is it reads this, it finds every image reference, every style sheet reference, every JavaScript reference, any other embedded elements, videos, audio, whatever, and then makes subsequent requests back to the server for every one of those elements. Then it parses CSS and it parses JavaScript and it tries to figure out all your goofy formatting and figure out how to draw a table and do all that other stuff that it does just to render out a web page. Error handling and everything else. So we say we build our request, build it up, get it together, whatever it is. In this case, it's just a simple direct request. We then say get response, which returns us a web response. And this is going to give us an error because the response is a web response. We're expecting HTTP web response. This is a superclass or an inherited class type off of web request and web response. So all the functionality for any sort of web request, just not an HTTP one, is built in to web request and web response. It starts to turn into a tongue twister. What's the difference? You can have other kinds of web requests besides HTTP. But HTTP in itself, because of the definition of what it is to do an HTTP request, has a lot of factors wrapped up inside of it. If you want to do an FTP request, that is not HTTP. That's File Transfer Protocol. Requesting a web page is an HTTP request. If you just wanted to do a generic request of any type, then you would just do a web request. Then you could do a DNS request, you could do a DHCP request, you could do Gopher if anybody still uses that. You have all these other options. but you're getting a request. So the mechanics here are, we say, hey, we need this page, the web server responds. So we're getting a web response. Inside of this response, it's going to give us a response stream, returning base class stream. I don't know if I covered var very much, but basically it's a inferred type. So stream takes on whatever type get response stream returns, which is a string. It can only be set to one type. It's still strongly typed. It's not like JavaScript where you can say, oh, now it's a stream and now it's a string. Once you have to initialize it when you use var, and once you initialize it, it takes on that initializing calls type. So this now is a stream. If that freaks you out, I will put stream. So now we have a stream. This stream has, again, the read, the write, and all those basic methods. I don't really feel like reading from the entire stream one byte at a time or in any sort of chunk. So what I'm going to do is I'm going to use system.io.streamReader. I'm going to put it around a using statement equals new stream reader and pass it the stream. So putting it inside of the using statement, and we can actually even move up one more level and put this inside of a using statement, allows us to not have to worry about managing opening the stream, closing the stream, just like the database connection. I didn't want to complicate this example, but this would be the same case. So you would then put a using statement here. Everything you do within that is handled here. Buffer is out of scope because it's within the curly brackets. So what I'm going to do is I like to copy, whack the data type, and then we'll move it up to the top to declare it. Initialize it inside the using statement, but declaring it outside persists it beyond the scope of the using statement. Okay? So this buffer is this buffer is this buffer is this buffer. Alright, so we now have the stream reader. Stream reader, we can do things like read, and we can read one byte at a time or a block at a time. We can say read a block, which will then read a block of text and automatically encode it into a character array. It's kind of fun, a little better. Read a line. Go and read a line of text from the file. It'll find a line break character. Yes, they really exist. Go to ASCIItables.com. And it will find the line break character or characters within the stream and return everything from the beginning up to that point. Then you read it again, and it'll start from that point and read to the next line break. If there are no line breaks, it will just read to the end, obviously. Or we can just simply say read to the end. String HTML. So I will just go ahead and store the entire stream into my HTML variable, and then I will say textbox1.text equals HTML. To read everything from the stream, store it in HTML, close my stream, and then put that HTML in the text box. Alright, so to trigger this, I need another menu item. Open URL. And I think I'm going to have to create a form. Create new form. URL prompt. make it pretty simple. Hello? Text box with an OK and a cancel. Alright, so then on click here I will say if, no wait, I will say URL prompt up equals new up show dialog equals okay. I forgot one thing. Prompt. Get that out of the way. So then what I will have is string URL. URL equals up dot. URL is what I want. And then I will say open URL. So I don't have any way of getting that text box data back from that form. So I'm going to say generate a property called URL. What that just did is it actually went into the URL prompt form and created a new public property called URL. Right there. Flip back to the designer. So I'm going to handle that button click a little bit. I'll say if txt URL dot text. I'm going to see if it's empty, so I'll say if string dot is null or white space. Message box dot show invalid URL. Try again. btnok dot dialog result equals false equals none. Okay. I think I might also have to set this dot dialog result equals that. So if it's good, then we'll say URL equals txt URL.text. Okay. I'm going to change this set to be private, which means that I can't try to like push some value inside of that property from the outside, but I can access it from the inside. So it makes the setting of that property private, only accessible from this form, but getting it is public. F6, good. F5, file, open URL. Hit OK. There it is. So that was an hour of watching me code. Questions? Yeah.
What if the URL that was inserted was an incorrect URL that didn't exist?
probably not a good one to search on. I'm assuming this doesn't exist. All right. You will actually get an error that occurs at the get response. So what's happening is that up to this point of calling get response, you're packaging up that request. You're preforming it. You're saying, okay, when I push this out into the pipe being the internet, I want it to look like this, have all these properties, all these attributes. Get response actually spins up that TCP connection, does the DNS resolution for the URL that you provided, tries to get the IP address, and then attempts to establish a connection on port 80. If it can't do one of those things, this is where you're going to get your exception. And this exception in this case is the remote name cannot be resolved. FuzzyBunniesLiveInFlorida.com. It doesn't exist. So the DNS resolution failed on that domain name. So we can wrap a try-catch block here and then push up message boxes saying, hey, this doesn't exist, or however we want to handle it. But that's where you would end up getting an exception. So if this was running not in debug mode, it would basically give you a nice, ugly Microsoft, this blew up warning pop up, and then the app would crash. So that's where your exception would occur. Other questions? So again, this concept of streams, you're dealing with data that flows or moves. The reason this is considered a stream is because not all of that HTML is technically coming across in one big chunk. It's flowing through the internet. It's flowing across the TCP connection. You see it as a big chunk of data because a lot of that work, that flow piece, is being handled for you, in this case, by the stream reader. So what this is doing for us when we say get response is it establishes a connection, it says, hey, I need this file. And the server says, got it. Here's position 0. That's what this is doing. Gives me position 0. The stream reader then says, oh, read to end? That's easy. I start at the beginning of the stream and I'll read it until it ends. If you ever look at an HTTP request, and maybe after the break I'll just pull it up so you can see it, there are requirements in all HTTP responses. One of those requirements is the length of the data being returned. And that's intentional. And so that you know how big the stream is, what's the length of the stream that you're trying to read. If you didn't know that, then you would be stuck in this perpetual state of reading bits, reading bits, reading bits, reading bits, hoping that one day it'll end, and then when it does, it just ends abruptly and the connection is lost. So then you have to handle it. You have to do a try-catch block, and you have to deal with that abrupt disconnection instead of making it a nice, smooth transition. So to eliminate that, having to spin up those expensive try-catch blocks and handling an exception, getting that length of stream in the header before the data actually comes is important. That's why when you read a file from disk, knowing the size of the file on the disk is important. If you look far enough down the stack in what a SQL Server call looks like, one of the first pieces of the response is, this is the length of the data. So that you have an indicator of how far, how long you need to read. How much memory do you need to read this file? If you're downloading a 100 meg or a gig file from the internet, you're downloading an ISO of Windows whatever or Linux or whatever it is, you know, those are gigs and gigs worth of data. Well, those are coming across as a stream. You'd never get that, you know, progress bar if it didn't know how long the file was. You guys ever do a download or it just spins and it says downloading 30 bytes, 40 bytes? Well, that's when you got a bad TCP connection or a bad server hosting up files, which happens, and it doesn't give them the length of bytes. So it just starts reading bytes until the connection terminates. So that's the scenario you do run into.